Hello all, I'm Dr. Rizvi and this is first lecture on simple stress and strain. And in this lecture we will discuss about stress and type of stresses. While studying strength of material, the first and foremost thing that comes in our mind is what is stress. When a body is experiencing an external force, for example, if we take this body and this is experiencing a tensile force P. When this body is experiencing an external force, it generally undergoes deformation. That means it changes its shape. When the load is tensile, the size or the length of the body will increase and it will get deformed on application of external force and the shape changes. The material of the body generally resists the external force and the tendency of that load to deform the body. At the point when the body becomes stable due to the internal resistance offered by the body, that stress overtakes the external force. This internal resistance of the body, which is offered to the external load, is known as stress. So the concept of stress is very simple. It is the internal resistance that is offered by the body, the material of the body, to the external applied load. P is the external applied load. And at a certain point, there must be the maximum strain that is developed in the body. After that, no further elongation will be observed in the body. At that point, the stability is obtained and we can find out the value of stress when the body is stable. And this is the internal resistance of the body. It is generally expressed in Newton per mm square or kilonewton per meter square or meganewton per meter square. Like these are the generally units in which we express stress. There are various type of stresses that a body is experiencing when it is subjected to external load. Now we will discuss the types of stresses. Basically, when we classification of stress, when we classify stresses, it is of three types. It can be a simple or direct stress, or it can be an indirect stress, or it can be a combination of direct and indirect stresses. Generally, the simple or direct stresses are of three types. It can be tension, it can be due to compression, or it can be due to shear. These two are known as normal stresses. Normal stresses. Talking about the indirect stresses, they are of two types. They can be resulting due to bending or they can be resulting due to torsion. So these are the basic categories in which the stress can be categorized. The first one is simple or direct stress. It is due to the tension, compression or shear. In this, tension and compression are basically the normal stresses. The second type is indirect stress, that results due to the bending of the material or due to the torsion that is occurring due to twisting movement. And finally, the third classification is based on the basis of combination of both direct and indirect stresses. In the present series, we will only discuss about the simple stresses. So, what is simple stress? It is the direct stress as it is developed under the direct loading condition. That means when the body is subjected to direct stresses, be it tension, be it compression, be it shear. When the body experiences these type of forces, the result is simple stress. When any type of this simple stress is developed, we can calculate the stress by the following formula. Basically, the normal stresses like tension and compression that are acting perpendicular to the surface are represented by sigma, and the shear stress that acts parallel to the surface like this, they are represented by Greek letter tau. Normal stresses are represented by Greek letter sigma, and the shear stresses are represented by tau. So these stresses results in simple, these forces results in simple stresses, and they can be calculated by, for example, we just write down the direct stress in form of sigma. Sigma is equals to P upon A, where P is the load or the external force that is acted upon the body like this, P, and A is the area. A is the area over which the stress is developed. In 3D we can see here that when a force P is acted upon this plane, so we will calculate the cross-sectional area A, and we divide P by A, and we can calculate the value of stress developed over this area. So for here, for this surface, sigma will be equals to P upon A. Thank you.